This is a PSA before we dive into actually planning a lesson. Doing the math is a critical component prior to actually planning a lesson. And doing the math from the student edition, it doesn't have all the notes, but it's really critical for us to really deeply understand the math ourselves. And I'm sure you're saying, when do I have time to do it? I don't have time to do the math. Well, I just want to tell you this, we can't afford not to. We can't afford not to. About 2 weeks ago, I was preparing to plan a lesson or planning a lesson with a teacher. And we just broke down, and all we did was say, okay, before we plan this lesson, we're just going to do the math. And what we started to recognize, it was certain nuances and certain things that were very different how normally we would have taught it, but it also allowed us to really deeply understand the math so that when students have those misconceptions, and we also thought about where did we struggle, that we can really support those students. So here's my plug, people. Before we plan, we gotta do the math. Alright, so the first thing that we want to do, we want to start with what is the standard of the lesson. And this is included in the curriculum map. But the standards for lesson 11 are A1.A.REI.B3 and also A1.A.SSEB3A. So let's just first take a look at REI B3A. And so if we look here, we see it says solve quadratic equations and inequalities in one variable and use the method of completing the square to rewrite any quadratic equation in x into an equation of the form x minus p squared equals x that has the same solutions. Derive the quadratic formula from this form. Also, if we're looking at A1.SSEB3B, actually, complete the square in a quadratic expression in the form ax squared plus bx plus c, where a is equal to 1 to reveal the maximum or minimum value of the function it defines. Now, I want to highlight here, if you look in this right column, it always provides us a scope and clarification in the Tennessee academic standards, and this kind of gives us a little bit of context about what that could potentially look like. So if we look right here, that we see that tasks don't require students to write solutions that have roots with non-zero imaginary parts. That's actually something they would do in Algebra 2. And if we look right here, it's also telling us that eventually this should be a real world context, which will let us know when we start making our customizations which ones are the most meaningful. The next thing that we want to look at is what is the aspect of rigor, but also push ourselves to think about in what way. So if you look here at the bottom, there's a document that gives us guidance in terms of looking for words that let us know what aspect of rigor should be taking place. So if we look, we have REI B3A. So this is this piece right here. So we see the word solve, which lets us know that we could potentially see a lot of procedural skill and fluency, but also using the method of completing the square to rewrite it in this form. That could be procedural as well as a piece of conceptual there. And now we look at the ASSEB3, which is choose and produce. So the choosing is actually the conceptual part, because again, when we talk about Algebra 1 and we talk about this seeing structure, we really want students to be able to use the structure to choose the best strategy to find the zeros or which form makes sense in the particular situation. So if we see right here, it says complete the square in quadratic expression in the form ax squared bx plus c. So that would also allow us to see that more than likely this is going to be procedural skill and fluency, but also a tinge of conceptual And if we look right here to the right for 3B, that it says tasks have a real world context, and we see this star, which lets us know that it is a modeling standard, which would say eventually this should be some form of application. Now that we have identified the aspects of rigor, we want to think about in what way. So the procedural skill and fluency piece is solving quadratic equations. However, in this lesson, they don't really solve quadratic equations. They are simply completing the square. And also conceptual understanding, using completing the square to rewrite it in an equivalent form. So that would be the conceptual piece. Now the standard specifically calls for application as well, but not in this particular lesson. And one of the things you want to keep in mind, I wouldn't have known that unless I did the math prior to the lesson. So this lesson does not have any application. So now we're at step 3, and we're thinking about what should students know and be able to do as a result of the standard. This to me is an extra bonus. I like to do this for me to more deeply understand what the standard is actually asking kids to do. But I want to give you 2 resources that you can quickly refer to gather that information. So one of the documents is the instructional focus document. So as you can see right here, it does not have all the standards. I want to go ahead and say that first. But it does provide context in terms of what is level 1, what is level 2, what is level 3, what is level 4. Because the state measures proficiency based on level 3 and level 4. So this can give you some guidance in terms of what students need to do right here, and this portion right here is about what teacher moves to get us there. So as you can see right here, level 3 and level 4, that'll just give us some guidance in terms of us internalizing math, but us really thinking about what students need to know and be able to do, so that when we do make those customizations, we can make the correct ones. Also, the Common Core Mathematics Companion Guide. So this to me it's like a Bible. It has everything that you need. It really unpacks the standards and helps you understand them in a deeper way. So that is another tool that you may want to consider using for that portion. But we're going to go ahead and move on to working the exit ticket. So the next thing that we are going to do, we are going to work the exit ticket. And they want us to do factoring, then completing the square. So I think we can all knock that out. R plus 3, R plus 1. And if we are completing the square, then we know that this would be we'll say R squared plus, actually let me go back. R squared plus 4R plus 3. So in the lesson, they actually use the area model of the tabular method. So we know that's R squared. And if we want to have the 2R, we know this has to be that way. So it has to be plus 2 plus 2. No, that's not right. Oh, yeah. Plus 4. Alright. So, what would give me 3? And so, that'll have to be R plus 2 squared. And I want to think about what number would give me 3. So, that would be minus 1. I almost forgot to answer this second part about which way is easier and explaining why I think so. So for me, I thought factoring is easy because it feels more simple. We want to think about what's the key understanding from this particular problem. And as I'm looking at it, well, first of all, what do you think? But what the next thing is, oh wait, let me backtrack. So I think the key understanding from this is, number one, using different methods to rewrite an expression, a quadratic expression actually. So they could use completing the square, or factoring. But I also think another piece here, my apologies, moved it down. Another piece here is, what's the most efficient strategy? The next thing we want to do is we want to just read the student outcomes of the lesson. And the student outcomes are to rewrite quadratic expressions given in standard form ax squared plus bx plus c with a equals 1 in the equivalent completed square form, a times the quantity x minus a squared plus k, and recognize cases for which factored or completed square form is most efficient to use. So we wanna go through and look at the key understanding here, but we also want to refer back to our standards. And we had these key things we pulled out: solving quadratic equations, completing square, using completing the square to rewrite an equivalent form. We had those things, and we also had this exit ticket where we identified the key understandings from this. So what we want to do is right here, if we had to say one headline for this particular lesson by looking for similarities in the student outcomes, the exit ticket, and the standard, and we just said, if we were like, this is just this big idea, headline, lesson 11 is about blank. And I want you to just take a second and think about what your idea of what you think lesson 11 is about. Awesome. I'm sure you came up with something great. But my thoughts were that lesson 11 was about rewriting quadratic expressions using completing the square. But it's also, again, using the structure to rewrite it. So choosing the best method too. Headline, big idea. So now we're moving on to step 6, which is looking for evidence within the lesson to see where we see evidence of the standard. So we also, what I want to highlight here is we also want to look at the discussion and the problem. So just going back to our standards, REI B3A, using the method of completing the square to rewrite it. So we're looking for evidence of that. And then 3A and B, which more of a focus on B, is completing the square in a quadratic expression in the form of ax squared plus bx plus c. So now we're going to look through the lesson and see where we see these things. Now I've already gone through and done that part, but looking for places where we see evidence. So definitely in the lesson notes. Also looking in the not only in the problems, but really taking a hard look at these discussions, because these are some of the key components that really build the conceptual understanding or pieces that are really needed for students to really deeply understand the content. And I'll just quickly show you where I put mine, and you can go in your lesson. This is actually on this page, and this is, I believe, the last page, so 138, and this is what I have on page 139. Awesome. The next thing that we want to do is we want to look at how does each problem build and how does it become more complex. So if you notice right here on the right hand side, I wrote a note highlighting what was the change from problem to problem. So the opening exercise is really connecting from prior knowledge. They've done some work with multiplying polynomials. They've done some work with factoring. And now they're kind of connecting that all together and trying to really see the structure in this expression. So they're starting there to give them an access point. But then from there, they're moving into another piece where they are actually factoring in ax squared plus bx plus c form in standard form. They're factoring from this form. And again, working on the structure, which I did not write, factoring in structure. And as we can see here, they're shifting, because this is a problem where they actually can't, they can't actually, I put can't complete the square, but it's actually they can't factor it the way that they did before. They can't factor. So now they have to use completing the square. So actually on that last piece right here, it's not can't complete the square, it's you can't factor. Like those. Okay. Alright, so they can't factor it. So now they have to use a different method. So it's almost showing them pulling another tool in the toolkit that they could use, and then also noticing structure and the area model as a support to teach completing the square. And now they're all in building from this last piece right here of this model. Now they're actually using completing the square. And they close out the lesson with building from here is the efficiency of the method. So if you look at this lesson summary, it highlights that piece right there. The next thing we want to do is we want to identify our must do, could do, and extension problems based on the evidence that we found so far, as far as right here. So on the opening exercise, that to me was a must do, because it's connecting prior knowledge and really allowing students to see that structure just like we wrote over here. But also I want to highlight, as I said in the last part, is that we also want to look at the must do discussions that could potentially take place, because a lot of the conceptual understanding is built in those discussions. Also, the first example I labeled as a must do, and I thought that these two questions were critical because they wouldn't be able to factor here. So I put that as a must do as well. Also, the exploratory challenge, I think that was huge. And specifically this discussion right here, like this whole discussion is critical, Because if I do this part, I allow them to explore, and I don't do this part right here about why completing the square works, then this next piece could fall flat. This piece right here could fall flat. So this whole discussion must do, as well as the exercises. So with the exercises though, this part I have not done yet, but the exercises, I thought that this first one was definitely a must do. So 1, 2, and 3 label as must do's. I thought this could or could not be must do. I might put this as a could do because the exit ticket does not have them utilizing fractions. This is a could do well as well, so maybe my high flyer finishes number 4. I could give them number 5 to really push themselves. And this I thought was a could do too, because again, the exit ticket does not say that they have to, but I do believe that 10 was an extension because they don't have, it's all variables. And I'm going to say that I think this falls between a could do and extension, but I'm going to say since it's getting further down there as an extension. And this I would say it's a could do. It doesn't absolutely have to be done, but we know the ones that have to are the ones that are integers because that's what is on the exit ticket. And also this discussion to close out the lesson, that would also be must do. This lesson summary, closing that out. And then this piece about the useful form, this note right there. And is there anything you notice about these two expressions? Although we can and complete the square for each, how else we might write. So that might be key as well. So these are must do's, could do's, extensions. And remember, the extensions are the ones that kind of push beyond where we need to go, and the could do's, we want to think of these as problems that are pertinent to the lesson, but if I don't have time, it's okay. One of the misconceptions as I worked through the lesson, I thought that students may struggle with trying to get this 13 and figuring out really like where does that come from. I could definitely see them getting kind of confused when we get to this point when they say, oh wait a minute, I can't use perfect squares, what do I do? So when I look back at it, I was thinking about how can I make this a tad more simple, but not necessarily taking away the understanding. I probably would let them jam with it and see if they could come up with it on their own first, because again, remember, it is an exploratory challenge. But one of the things I thought that might make it a little bit easier, because we've already used the area model to help us do that, is go ahead and let them do this part, and we've already kind of talked about this part right there. So we would say what would be the product of these two, 16. We spent some time there. So what I may do is put a little highlight around that box and really ask them plus what will give me that, because we know x squared plus 8x plus 16 is x plus 4 squared. So I need to get it to equal, I actually probably shouldn't put a box around that because that could be confusing. How can I get it to equal 3? What value would make that true? And so initially students may say, as I was looking at the teacher notes, that they may say, oh, I'm just going to add 13 to 3, but that's not necessarily true. So I'm thinking, what value can make it true? Oh, minus 13. Because 16 minus 13 would give me 3, or negative 13. So I may say x plus 4 squared minus 13 is equivalent to, this part right there. So that's what I'm thinking. But again, there are multiple misconceptions that could come up in a lesson, but I definitely could see students not understanding how to get to this value. That could be very confusing. I thought this was a way to make it just a tinge more simple for them. But please feel free to comment below and share what strategies you think may be better suited. I know one of the things, and I think in the next lesson they talk about 0 pairs, why it wouldn't be plus 13. But yeah, please share below. I'd love to hear your comments on some different misconceptions and what strategies you think would be good to address it. So the next thing we want to think about are, where do we want to place intentional checks for understanding? Because we want to have certain checkpoints throughout the lesson to ensure the students are still following along. I like to use the analogy of when you go into the grocery store and the kid is still the daycare. You want to make sure that they are still in the back seat of the vehicle as you drive to the store. So you want to check every few minutes, or consider there are certain checkpoints in the lesson and certain understandings that they have to get at each point in the lesson to ensure that they get towards mastery at the end. So if we're looking at this first exercise, maybe at this fourth one, just making sure the students are still following along and they are kind of able to do what they need to do. But definitely after they complete this opening exercise, summarizing and having some sort of check for understanding, whether that be whiteboards, sharing student work. I think this conversation right here could be a critical piece there, but definitely some type of summarizing after this piece right there. After we complete example 1, because again, they are supposed to work in pairs right here to complete this table. Definitely some type of check for understanding. After this portion. But as I'm working through this, I'm thinking that on the front end of the lesson, I may do a rapid whiteboard exchange to kind of get them warmed up to the idea of factoring. So that's something to think about, because they're really going to need to be able to factor these types of expressions throughout the lesson, and also be able to multiply binomials. So that might be something that, as I'm working through with them, like, man, I definitely need to warm them up in the beginning of the lesson. So the exploratory challenge is us kind of modeling a little bit for students, using this area model and building that understanding of what completing a square is. But these questions right here, we've already selected them as must-dos. So maybe again, allowing maybe like modeling this first one just to make sure that they still have it, and then the second one maybe doing together, and maybe using this one as that problem is like, okay, I need to make sure that they following along and they still in the vehicle. So maybe a quick check for understanding. Or as I looked at it, I even thought about maybe adding a 0 problem. So I created 2 0 problems. These are just in case, having them in the toolkit just in case I need to maybe do another guided problem, or if I need to maybe change one of these problems to a check for understanding. But I have 2 in the toolkit that I can pull from just in case for a CFU or another problem to guide students through. Okay, so we are finally at the last step, step 12. What are the engagement and instructional strategies that I will use to reach the outcomes? I want to provide you with 2 tools to support you in identifying those, and then we'll actually go back to the lesson and think about some instructional strategies we can use. We're looking for 2 things. Number 1, we're looking for ways in terms of teacher moves that we can add, but also how can we really shift the cognitive load for students? How can we get students engaged in the content where it's not just us talking and the students are just sitting there, but we're giving them an opportunity to actually talk about the math and have some discourse in the class, or get up out of their seats and be really involved in the process of learning. So the first I want to give you is the EL protocols. So they have several. This one right here is money in the bank to me. I just love this little strategy. Back to back, face to face. We've practiced it at a few schools this year, but I will provide a link to this document in the notes below. But this is money in the bank in terms of how can I really engage students. And these are EL protocols. Now they have multiple, but this is one I just love this to death. Now the second one is the mathematical language routines, and these were created to help students have access to challenging content, but also really around the language of math. But these are also some really great strategies to support students and having some conversation as well. So this one right here I pulled up is, I think this is MLR for short, MLR 1. And so think successive pair shares. So this is one of the strategies you can use, but they also lay out specifically how to do it. It's very, very clear, very explicit. But this one is, I really love this strategy right here. Convince yourself, a friend, and a skeptic, because it really is asking students not only what they're doing, but how they're doing it and why they're doing it, which I think is really awesome. So these are some strategies that you can use, and now we're going to dive into the actual lesson. And these are some tools, and I'll provide a link to both of them in the notes. Actually, there's one more tool that I want to highlight that can be really beneficial, and this is the IPG. Because in terms of planning, it really allows you to think about what is it that I really need to happen to really have standards aligned instruction. So core action 2 specifically, because it's thinking about how am I going to present it, but also thinking about how can I share students' work and solution methods. And we've already addressed some of this part right here in terms of checks for understanding and misconceptions, and then also that summarizing the math with student work. And this part right here is really about student engagement. So us thinking about where can we ask questions in the lesson, where can we have opportunities for student conversation. But this is a really great tool in terms of when you plan your lesson to have beside you and think about where you can incorporate some of these strategies. So now we're at step 12. We have some additional tools to help us in thinking about instructional strategies, but I want to let you know that Eureka gives us guidance in terms of how to roll this out to kids. So for instance, if I'm looking right here, it says project or draw the table on the board of the screen. That's something that we need to know. So when I'm thinking about materials, I'm like, okay, I need to have this table ready to go. So if we see right here, we're actually filling out that first row. So we're modeling the first row. And then it says have students work in pairs. So that's another note. So we need to have this table ready to go. We're going to model that first row, and then students are going to work in groups, in pairs. And so they'll continue filling the blanks and writing down their observations. So that we'll think about that. Consider how much time will 5 minutes work for your students. Do you need 7? So those are things to think about. And then this portion right here looks like this is going to be some type of discussion, but again highlighting so you know this is the question I'm going to ask. But thinking about how could students respond too. So maybe having some additional questions in the queue, or additional answers in the queue of things that they could potentially say. All right, so now let's move on to the second example. So again, they're continuing to work in a pair. So that's something we need to highlight. Students are working in pairs in this part, and then encourage them to use patterns to discuss to above define the factor form efficiently. So that's something key, because remember, the key about these standards in terms of structure is they're trying to find the most efficient way. And they're also giving us some context here. But again, there's another discussion right after this, but we've already said that there should be some type of summary after this part. We definitely need to make sure that they're able to do these two things. Again, checks for understanding to make sure that they're still following along. Alright, so it doesn't really give us any guidance around the exploratory challenge, but it does tell us what to do right here. So this is a really big part right here. So this is actually addressing coherence, or when we talk about core actions, this is actually core action 1B, which is connecting to prior knowledge, because they learned this in lesson 2 and now they're doing it again with the perfect square binomial. So they're telling us right here that this expression, we need to write it on the board, and we're going to lead them through this process. So because it's so many words, you may just want to write yourself a note and say, I'm just going to lead them through process below. But they really give some good guidance. And then if you see right here, if students have not already come to the conclusion, point out that the constant term in a perfect square is always half of B. So that's something we need to emphasize. Alright, so we're still in this discussion again. It doesn't really give us any guidance here. So as we already kind of talked about this part, maybe modeling that first one to make sure they still in the car, then going through another one together, checking to see if they still kind of following along, and then we have these questions in the queue. Now it may be something where I'm thinking that when I do this check for understanding, or maybe when I allow them to work on a few by themselves, I may do maybe 3 minutes of private think time to just let them see what they know, and then maybe a think, pair, share to discuss their thought process. And then once they do that, maybe use some student work. And so maybe I might put a note that I need to be circulating around the room to identify some student work that I want to share. So I may put a note right here that we're going to have a discussion, maybe a discussion around that check for understanding, using still sharing student work, maybe having multiple students, even the incorrect answers, multiple students. So I'm going to look for an incorrect solution as well as a correct solution, because I know that I'm thinking about that problem right there, that I'm anticipating that a student could say n squared minus 2n minus 15, that they may, when they get to this part, instead of a certain operation, they may do the opposite, just like in this problem where some students might add 13 instead of subtracting 13. So kind of preparing myself for when that happens. But I'm going to be looking for a student that does that. So I'm looking for an incorrect solution as well as a correct solution. But also when they come to the board, have them justify their thinking. But not just steps, but really their mathematical thinking. I chose this strategy because of this. This is why I'm going to do that. So that's something else for us to think about. I didn't see any places for back-to-back face-to-face yet. But then this discussion here. Oh, but I wrote this down as a must-do too. I forgot I wrote that in there. So that could be another problem that we can use. Maybe doing that one, have them do that one on their whiteboards as an additional check, additional CFU, just to make sure they still in the car. And then maybe having a discussion using some of the student work to close out their discussion, but really highlighting that part in the key box. Highlight lesson summary. And maybe even asking students about what do they think the key understanding is of the lesson and see if it matches what they have in the box. That's something else to think about too, but not necessarily. But then closing it out with exit ticket after that. So we are officially done. I just want to thank you again for tuning in, and hopefully we can do this again. Talk to you soon.